Hi guys! Have you ever wondered how this pressure cooker works? How about the aerosol can or even the vehicle tire bursting on a hot summer day? Well, in this video, you will learn all those concepts on how these things work through the use of the Lusac's law of gases. Well, hello, my name is Vincent Elcano and welcome to the concepts of Gay-Lussac's law.
So, who's Gay Lussac? My name is Linjilianes Alvarez, and for today's video, we will find out who's Gay Lussac is. Joseph Louis Gay Lussac was born on December 6, 1778 at Saint Leonard de Noble, France. Died on May 9, 1850 at Paris. He was a French chemist and physicist. He showed that all gases expand by the same fraction of their volume for a given temperature increase. This led to the devising of a new temperature scale whose profound thermodynamic significance was later established by Lord Kelvin. Taking measurements from a balloon flying more than 20,000 feet or 6,000 meters high, he concluded that Earth's magnetic intensity and atmospheric composition were constant to the altitude. With Alexander von Humboldt, he determined the proportions of hydrogen and oxygen in water. He is remembered as a pioneer investigator of behavior of gases and techniques of chemical analysis. He is a founder of meteorology and made a notable advances in applied chemistry.
Because of the extending investigation and scientific experimentation, Joseph Louis Gay-Lussac opened up the concept of the gas law. Through his daring accent in hydrogen-filled balloon is the key to the success of his investigation. Gay-Lussac proposed two fundamental laws of gases in the early 19th century, but he is known for his works like Gay-Lussac's law of gases.
Hi, my name is Randall Ramos. Welcome to Trivia and Facts according on Gay-Lussac's law of gas. I know many of you didn't know about these fascinating and awesome facts that will probably make you mesmerized about the concept of Gay-Lussac's gas law. Now, let's start. Did you know that the air pressure inside of a car tires goes up? This is because the friction between the tires and the road causes the air inside of a tire to heat up. The air cannot be expanded because the tires are essentially a fixed volume container so that the pressure will increase. And again, that's just one of the most interesting facts about the Gay-Lussac's gas law.
Now, let's talk about the concept of the Gay-Lussac's law. Here, we need to understand the relationship between pressure and temperature. We need to also consider that these two factors are directly proportional to each other. Now, in the concept of Gay-Lussac's law, if the pressure goes up, the temperature will also goes up. However, if the pressure goes down, the temperature will also goes down. Now, to better understand this concept, we need to see the mathematical concept of this law, which is, now, we see that this formula can help us understand the concept of Gay-Lussac's law. However, we do not yet know what do we mean by P1, T1, P2, and T2. So, let's start with P1. P1 means initial pressure. T1 means initial temperature. P2 means final pressure, and T2 means final temperature. Now, in this general formula, we can rearrange it to find the specific value that we are finding for a given question. So, to do this, we can rearrange it. For example, if we are looking for the final temperature, we can use the general formula and rearrange it. First, P1 will be cross-multiplied to T2. So, T2 will go up and go to the side of P1. And T1 will be cross-multiplied with P2, which means that T1 will go to the side of P2. So we're left with P1 times T2 is equals to P2 times T1. Here, we need to understand that we are looking for final temperature, which is defined as T2. So, to get the final formula, we need to divide it both sides by P1. So, by dividing it by both sides by P1, we can cancel out the same value in the numerator and denominator in the in the other side of this formula. So, we left with T2 only. Now, in the other side of the formula, we left with P2 times T1 over P1. So, this is our final formula if we are looking for final temperature. The same with if we are looking for other values. If we are looking for P2 or our final pressure, just do the same thing. Now, let's solve a problem considering the Gay-Lussac's law in real life. Now, let's consider this statement. The pressure in a car tire is 198 kilopascals at 27 degrees Celsius. After a long drive, the pressure is 225 kilopascals. What is the temperature of the air in the car tire now? Assume that the volume is constant. So, the next thing we are going to do is to write all the given values. For our P1, we can say that it is 198 kilopascals. And for our initial temperature is 27 degrees Celsius. And our P2 is 225 kilopascals. Here, we are not done yet in these given values because we need to convert Celsius into Kelvin. To do that, just add 273 to the value of Celsius. So after adding them, we get 300 Kelvin. After getting it, let's now find what value are we going to find. Based on the statement, what is the temperature of the air in the car tire now? Which means that we are looking for the final temperature. Now that we find out that the final temperature is our main objective here, we are going to rearrange the general form of formula into another form to get the final temperature. To do this, just cross multiply the general formula and do other things like this, okay? Now, after putting them into another form of formula, we can place the values, okay? 198 is our P1, so which means it is our denominator. P2 is our numerator. That means 225 kilopascal will be placed as a numerator times the initial temperature, which is 300 Kelvin. By multiplying them, we get 225 times 300 is equals to 67,500 over 198 kilopascals. Here, we will be cancelling out the same units and we will be left with Kelvin because what we are looking here is not pressure but temperature. So, Kelvin must be our unit left. Kilopascals in the numerator and kilopascals in the denominator will be cancelled out. After cancelling them out, just divide 67,500 over 198 and we will be producing 340.90, which means that our temperature is very high after getting a pressure of 225 kilopascals, which is the same concept we are talking about lately. That if the pressure goes up, our temperature must also goes up. However, if our pressure goes down, our temperature must also goes down, which is evident in this question. That is why we can conclude that the pressure increases and our final temperature must also increase, which is, it becomes 340.91 Kelvin. And that is one of our examples.
So for our second example, the pressure of a gas in a rigid container is 125 kilopascals at 400 Kelvin. What will be the new pressure if the temperature increases to 800 Kelvin? Now the temperature increases from 400 Kelvin to 800 Kelvin. Basically, it increases by a factor of 2. 400 times 2 is 800. So therefore, the pressure should increase by a factor of 2. So 125 times 2 will give us a final pressure of 250 kilopascals. So, if the numbers are nice and easy to deal with, you can calculate the final pressure mentally. Sometimes you might have a problem that doesn't have a nice numbers like this, so let's get the same answer using the equation. And our goal is to calculate and find the value of P2. So we're going to use the equation P1 over T1 is equals to P2 over T2. P1 is 125 kilopascals, T1 is 400 Kelvin, and T2 is 800 Kelvin. So what I like to do at this point is cross multiply. So 125 times 800, that's going to be a 100,000. And the units I currently have is kilopascals times Kelvin. And then that's going to be equal 400 Kelvin times P2. So divide both sides by 400 Kelvin. So all I have left over is simply P2. On the left side, Kelvins will cancel, which means the unit for P2 is going to be kilopascals. So 100,000 divided by 400 is equal to 250 kilopascals. So that's how you can use the formula to get this answer.
Well, here are some of the application of the concept of the Gay-Lussac's law of gas. The pressure cooker is one of the most popular kitchen equipment in the 21st century. So, what is a pressure cooker? The pressure cooker is a sealed container or utensil used for cooking food under steam pressure. The concept behind of this is applying a heat to a pressure cooker also increases the pressure inside the device. Increasing the pressure also raises the boiling point of the water and it shortens the cooking times of the food. So that's how it works, the pressure cooker. The increase of the pressure is due to the Gay-Lussac's law of gas. So, the pressure of a fixed amount of gas increases with its temperature at constant volume. So that's how the concept of pressure cooker is applied in the real life situation like using the pressure cooker. Another one of the application of the Gay-Lussac's law of gas is the aerosol can. When an aerosol can is exposed to a hot environment, the propellant gas vaporizes. Due to the vaporized gases, it exerts the pressure to the wall of the can. The pressure on the wall increases as well the temperature as per Gay-Lussac's law. And then, the aerosol can bursts out when the pressure is intolerable. This is the reason why we should not expose the aerosol can in a hot or high temperature environment. And that's all the application of the Gay-Lussac's law.